Okay. Before we begin, can you tell me the series for e raised to x? It is 1 plus x square by 2 factorial plus x cube by 3 factorial plus x raised to 4 by 4 factorial plus etc. Right. What is the series for sin x? X minus x cube by 3 factorial plus x raised to 5 by 5 factorial minus x raised to 7 by 7 factorial. Series for cos x is 1 minus 2 factorial plus x raised to 4 by 4 factorial minus x raised to 6 by 6 factorial. Now we will just confirm. We have studied something like e raised to ix, and if I write the series, it will be 1 plus ix plus I square x square by 2 factorial plus I cube x cube by 3 factorial plus I raised to 4 x raised to 4 by 4 factorial plus etc. That becomes 1 plus ix. I square is minus 1, so minus x square by 2 factorial. I cube is minus I, so minus I x cube by 3 factorial. I raised to 4 is plus 1, so plus x raised to 4 by 4 factorial. I raised to 5 will be I x raised to 5 by 5 factorial. I raised to 6 is minus 1. And if we just collect real and imaginary part, 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial etc. plus I into bracket x minus x cube by 3 factorial plus x raised to 5 by 5 factorial etc. And that gives us cos x plus I sin x. We haven't explained it at that time why it is e raised to ix is cos x plus I sin x, but the explanation is here. And remember that we will be noting this down. The reason is we also have a topic called as infinite series and some other parts where we will require all these series and all of them, right from e raised to x, sin x, cos x, tan x and whatnot. So many series are required, right? So make a note of this before we begin with the next part. And obviously we will get e raised to minus ix will be cos x minus I sin x, because that minus 1 raised to n will come into picture. sine and cos are real functions, right? Okay, and they get themselves expressed as, how will you write cos x? It will be obviously e raised to ix plus e raised to minus ix upon 2, because if we simply add these two, then I sin x will get cancelled. So 2 cos x is e raised to ix plus e raised to minus ix. So cos x is half. And similarly, sin x will be written as e raised to ix minus e raised to minus ix upon 2I. And this leads to the definition of what they define it as: sin x is equal to, and it is defined as e raised to x minus e raised to minus x upon 2, and cos x is defined as e raised to x plus e raised to minus x upon 2. So what we have done, we have simply replaced ix by x and we have defined it as hyperbolic. What would be the series in this case? What will be the series of sin x? This is just the subtraction of odd terms, because odd terms over here e raised to minus x will have negative sign. E raised to x is 1 plus x square by 2 factorial plus x cube by 3 factorial, whereas e raised to minus x will be 1 minus x plus x square by 2 factorial minus x cube by 3 factorial. So when we subtract, even terms will cancel and odd terms will add. They will become twice and that 2 will cancel. So sin x will be x plus x cube by 3 factorial plus x raised to 5 by 5 factorial plus etc. And cos x will be 1 plus x square by 2 factorial plus x raised to 4 by 4 factorial plus etc. Right? So this is altogether a new definition. We pronounce it as sin x or sin hx, whatever, and cos x or cos x, right? And now if I try to find what is sin ix, then by definition I should simply substitute. What do I get? I will get it as e raised to ix minus e raised to minus ix upon 2. Right? But this is what we know, that sin x is e raised to ix minus e raised to minus ix upon 2I. So this I should be transferred. So this will be I sin x. So sin ix is I sin x. Okay. What will be cos ix? It will be e raised to ix plus e raised to minus ix upon 2, and that itself is cos x. There is no I. So sin ix is I sin x. Cos ix is cos x. Good. It is interesting. Sin of ix then you will have to recall the definition of sine and substitute x equal to ix. So it will be e raised to minus x minus e to the power x upon 2i. So this is somewhat similar to this, but with a minus sign. So if I take out that minus sign, minus 1 and I, it is e raised to x minus e raised to minus x upon 2. What is minus 1 upon I? I square is minus 1. So we know that I into I is minus 1. So I will be equal to minus 1 upon I. And so this becomes I sin x. Similarly, cos ix will be e raised to minus x plus e raised to x upon 2, which is cos x. So are you getting the point? कि क्या हो रहा है? It is all leading to some. It is sin ix is I sin x, sin ix is I sin x, cos ix is cos x, cos ix is cos x. Right? So while mugging up also you will have to mug up that h correctly. Otherwise you will say cos ix is cos x. मर गए. It is cos ix is cos x, cos ix is cos x, sin ix is I sin x, sin ix is I sin x. Okay, make a note. And we are still dealing with only sine and cos. So there will be tan, sec, cosec, cot. Now tan x is defined as sin x upon cos x. So also tan x is defined as sin x upon cos x, that is e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. So what will be tan x? It will be sin x upon cos x. What is sin x? I sin x. So it is I sin x upon cos x is cos x. Answer is I tan x. Tan ix is I tan x. Cosec hx is 1 upon sin x will be obviously 2 upon e raised to x minus e raised to minus x. Sec hx is 1 upon cos x is 2 upon e raised to x plus e raised to minus x. And cot x is 1 upon tan x is nothing but e raised to x plus e raised to minus x upon e raised to x minus e raised to minus x. Probably the entire lecture of today's will be only the formulae. And then as usual, value of x and corresponding values of sin, cos and tan. And here the values vary from minus infinity, 0 and plus infinity. So sin is defined as e raised to x minus e raised to minus x upon 2. When I put infinity, minus infinity, e raised to minus infinity is e raised to infinity is infinity. E raised to infinity is infinity. E raised to minus infinity is 0. 1 upon e raised to infinity. That is 1 upon infinity. So this term will be 0. This term will be minus infinity with minus sign, minus infinity. So sin minus infinity is minus infinity. Cos minus infinity. Infinity by 2 is infinity. Infinity plus 1 is infinity. Infinity plus 10 is infinity. Infinity into 10 is infinity. Log of infinity is infinity. So what will be cos? Cos of minus infinity? Plus infinity. And then comes tan. It can be, because it is e raised to x minus e raised to minus x upon e raised to x plus e raised to minus x. If I divide numerator and denominator by e raised to x, it will be 1 minus e raised to minus 2x upon, rather ulta, I multiply by e raised to x. So e raised to 2x minus 1 upon e raised to 2x plus 1, and I put x equal to minus infinity. This is 0 minus 1 upon 0 plus 1. Answer is minus 1. So it is not indeterminate. You will have to adjust it differently. Then sin 0. This is our formula for sin. E raised to 0 is 1. E raised to minus 0 is e raised to 0 is 1. 1 minus 1 by 2, so 0. Cos 0. ये cos का formula. 1 plus 1 upon 2, so it is plus 1. Tan 0. So this was our formula for tan is 0. Sin infinity. Sin, this formula, e raised to infinity is infinity, e raised to minus infinity is 0, So this will be plus infinity. Cos infinity, this formula, infinity plus 0 by 2, so infinity again. And tan infinity, now I should write it as 1 minus e raised to minus 2x upon 1 plus e raised to minus 2x. And this will be 0, so this will be 1. And what an interesting result now. We had tan going from minus infinity to plus infinity, right? Here tan gets confined between minus 1 and plus 1, right? Sin varies from minus infinity to plus infinity, where cos cannot become negative, and minimum value of cos is 1. Got it? So the things will change now. This particular curve, cos, is actually called as catenary, and this is the curve for cos. At minus infinity it is plus infinity, at 0 it is 1, and it again goes to, not a parabola, it is continuously increasing. We have got a topic called as curve tracing in M2, where we are required to trace the curves. Okay, over there this is one of the famous curve called as catenary, y equal to cos. Sine curve, you can always draw it as minus infinity, so here it is this way, here it is this way, whereas our tan was between minus pi by 2 and plus pi by 2. So this is from minus infinity to plus infinity. And if you try to draw the curve for tan, it will be minus 1 and plus 1, and it has to go like this. That will be the curve for tan. Could be useful only for your online exam. What is the curve of the particular curve, shape of the curve, sin, cos and tan. I will draw them separately for you, so it will be useful. Otherwise, make a note of this table. Curve for sin is going to be for cos, the curve is, this is 0.1, it goes like this, and for tan you will have to consider this is minus 1 plus 1, this is your x-axis, y-axis. The curve will come asymptotic to minus 1 and will become asymptotic to plus 1. These are 9 questions in your online exam. What is sin 0? What is cos 0? 1, 0, minus 1, infinity. Those are the options like. Okay. Each of this value can be asked. And now we will go with our basic identities in trigonometry. On one side it is sin square x plus cos square x is 1. जाऊ दे 1. And to get the corresponding identity, we will simply put x equal to iy and proceed. So that sine will get converted to sinh, cos will get converted to cos with some that I multiplying it, and we get the new identity. So I remember the basic and write it as it is sin square iy plus cos square iy equal to 1. But sin iy is I sin y. So it is I sin y bracket square plus cos y bracket square equal to 1. And then I square becomes minus 1. So identity in hyperbolic is cos square y minus sin square y is 1. And here we had sin square x plus cos square x equal to 1. Now our next identity was 1 plus tan square equal to sec square, right? It was 1 plus tan square x is equal to sec square x. Now how did we get this? This we have obtained dividing throughout by cos square, right? So it was sin square upon cos square, that is tan square, plus 1 equal to 1 upon cos square, so sec square. So here also we will divide throughout by cos square, will lead to 1 minus tan square y equal to sec h square y. Here we have divided by cos square, over there we divide by cos square y. Then if we divide by sin square, we have formula 1 plus cot square x is equal to cosec square x. And here if we divide by sin square, then we have cot square y minus 1 equal to cosec h square y. And that's why I say that it is better to remember this and only the basic formulae. Sin ix is I sin x. It is better to do that only. Or these formulae, they will, because they will make total mess here. And there is a problem only with the sign. Plus or minus. See, there is no, over here we have a consistency. 1 plus tan square is sec square, 1 plus cot square. Here it is 1 minus tan square is sec h square y. Cot square minus 1 is cosec h square y. Right. Now we have a formula sin 2x as 2 sin x cos x. Right. If I substitute iy, it will be sin of 2 iy. Right. So I will do it that way. Sin of 2 iy equal to 2 sin of iy into cos of iy. Sin of iy is I sin, so it is I sin 2y equal to 2 into I sin y into cos y. and I cancels from both sides, so we get a formula sin 2y equal to 2 sin y cos y, and formula again turns out to be the same. Cos 2x is cos square x minus sin square x. So it will be cos of 2iy equal to cos square iy minus sin square iy. Cos 2iy is cos 2y equal to cos square y minus I sin y bracket square, because sin iy is I sin y, and it becomes I square, and with a minus sign becomes plus 1, and we get a formula as cos 2y is cos square y plus sin square y. Here we have the other formula as 2 cos square x minus 1 and 1 minus 2 sin square x, right? I won't substitute into this, but instead remember that we have the basic formula with which I will calculate. We know that, but cos square y minus sin square y is 1. So if I am to bring everything in terms of cos or everything in terms of sin, I will make use of this. Okay, so suppose for cos square, if I substitute 1 plus sin square here, I get the second formula as 1 plus 2 sin square y. When I have substituted cos square y as 1 plus sin square y, and if I am to substitute sin square y, then it will be cos square y minus 1. So the second formula is 2 cos square y minus 1. So remember only the basics, that is still the thing. We can derive the required formula, that is not a big deal. I am not substituting even Iy now. I am using only the basic formula to go further. Now using this only, we had formula like cos square x is 1 plus cos 2x upon 2, and sin square x is 1 minus cos 2x upon 2, right? So what will be cos square y? It is 1 plus cos 2y, right? 2 is a bad practice to write it like this. We should write it as cos 2y plus 1. And what will be sin square y? It will be cos 2y minus 1 by 2. So corresponding to these two, we have these two. What was the next formula that we had in trigonometry? Tan 2x. So tan 2x is 2 tan x upon 1 minus tan square x. Now it will be, you can go with the basics also, it is tan iy, rather tan of 2iy equal to 2 tan iy upon 1 minus tan iy square. And so we get I tan 2y equal to I, rather 2i tan y upon 1 minus I square tan square y. Cancelling I, we get formula tan 2y is equal to 2 tan y upon 1 plus tan square y. Sin of a plus b, we have formula as sin a cos b plus cos a sin b. So if I go with sin of I into a plus b, so it is IA plus IB actually. So it will be sin IA cos IB plus cos IA sin IB. Sin of I into a plus b is I sin of a plus b. It will be I sin A, cos IB is cos B, plus cos IA is cos A, and sin IB is I sin B, and I cancels throughout. We get the formula sin of A plus B is sin A cos B plus cos A sin B. Formula again remaining same. So obviously for minus it will be minus. And unfortunately in this hyperbolic functions, this particular chapter, we don't have two problems which are identical. Every problem requires one different formula and it has to be tackled in that manner. So we cannot just decide a procedure like we had in matrices or earlier complex. Okay, we can solve it like this. No. Sometimes the answer gives us the clues. Sometimes we will have to take, remember something and proceed. I am not frightening you, but I am telling you the importance, because each formula over here will lead to one problem. And that too in online, each formula is one online question. Because then what will be the formula for cos of A plus B? You can just do it orally. It is cos A cos B, and minus it was I sin A I sin B. So minus minus it becomes plus. So formula for cos of a plus b, cos of a plus b is cos a cos b plus sin a sin b, and again here is a difference, and for plus plus minus minus. If you remember these four, then the next problem will be obviously what is 2 sin a cos b, sin of a plus b plus sin of a minus b, like that. What will be tan of a plus b? It will be tan a plus tan b upon 1 minus I tan a I tan b. So it will be 1 plus tan a tan b. Then even remember these. Sin x is 2 tan x by 2 upon 1 minus tan square x by 2. Cos x is 1 plus tan square x by 2 upon 1 minus tan square x by 2. And tan x is obviously ratio of these two, 2 tan x by 2 upon 1 plus tan square x by 2. We have written actually tan 2x, but we require even these two. It is sufficient that if you remember all the formulae of trigonometry correctly and put x equal to ix, and you will be through. It is possible. Yeah. But it will always lead to 10-15 seconds extra every time you use the formula. Now d by dx of sin x. For that we have only one thing, that it is d by dx of e raised to x minus e raised to minus x upon 2, which will be half. Differentiation of e raised to x is e raised to x minus minus plus e raised to minus x, which is nothing but cos x. So d by dx of sin x is cos x. Now d by dx of cos x, it will be half d by dx of e raised to x plus e raised to minus x, which is half into bracket e raised to x and minus e raised to minus x, which is sin x. So differentiation of sin x is cos x, differentiation of cos x is sin x. Over there differentiation of cos is minus sin. Differentiation of Tan x comes out to be sec x square. You can use that differentiation formula, use u by v, and you will get it as sec h square x. And obviously the integration of sin x is cos x, integration of cos x is sin x, integration of sec x square is tan. Integration differentiation we won't require probably in M1, but in M2 it will be, because M2 is totally on integration and differentiation, right? Write down inverse hyperbolic. Now we require formula for the inverse hyperbolic. Suppose x is equal to sin y. Then obviously you will write it as y is equal to sin inverse x. Y equal to sin inverse x. So we require a formula for sin inverse, right? How it is to be written? It should be y. If we write y, it is sin inverse x. Now see how we do it. We start with again x is equal to sin y, and we write its definition. It is e raised to y minus e raised to minus y upon 2. Right? Now forget this. It is 2x is equal to e raised to y minus e raised to minus y, and I multiply throughout by e raised to y. So it becomes 2x e raised to y equal to e raised to 2y minus 1 multiply by e raised to y, and take it on one side. So it is e raised to 2y minus 2x e raised to y minus 1 equal to 0, which happens to be a quadratic in e raised to y, right? And so using quadratic formula, e raised to y will be, what is b? B square minus b, that is 2x, plus or minus under root b square minus 4ac, so 4x square plus 4 upon 2a. We just ignore this minus sign and we cancel 2 throughout. So it is x plus or plus under root x square plus 1, and therefore y will be log of x plus root of x square plus 1, and we get a formula sin inverse x is equal to log of x plus root of x square plus 1. Right? Ignoring the negative sign associated with x square plus 1. We can justify it later. For the time being it is okay. Why it is ignored, that also I can tell you. It is very simple, because if you carry out with that minus sign, second term is definitely greater than x, and it will be x minus a value greater than x, so it will be a log of negative entity. That is a problem. You can't find log of negative, and that's why it is ignored. Make a note and then give me a break of 5 minutes when you will find the formula for cos inverse. Start exactly on the same lines. X is equal to cos y, y equal to cos inverse x equal to cos y. Write the formula, multiply by e raised to y, you will get quadratic. Substitute, get the formula as x plus under root of x square minus 1. Okay, next is x is equal to tan y. Therefore, y is equal to tan inverse x. We again start x is equal to tan y, which is e raised to y minus e raised to minus y upon e raised to y plus e raised to minus y. And we will not go for anything further like equation. It will be component derivative. Yeah. But so how should we write? X plus 1 denominator, numerator plus denominator. So you want it like this. So he is trying this way. And then it is 1 plus x upon 1 minus x equal to e raised to y plus e raised to minus y plus e raised to y minus e raised to minus y upon e raised to y plus e raised to minus y minus e raised to y plus e raised to minus y. So here e raised to minus y will cancel, here e raised to y will cancel. You will get e raised to 2y upon e raised to minus 2y, that is e raised to 4y. Nahin, it is 2 e raised to y upon 2 e raised to minus y, sorry. So you get e raised to 2y. E raised to 2 e raised to y upon 2 e raised to minus y gives us 2 e raised to 2y, and therefore 2y is equal to log of 1 plus x upon 1 minus x, or y is equal to half log of 1 plus x upon 1 minus x, that is tan inverse x is equal to half log of 1 plus x upon 1 minus x. What next? X is equal to sin y. Therefore, y is equal to sin inverse x. This is what? No. We even know the formula for it. Now suppose I go with x square is equal to sin square y, and we know that 1 minus, rather cos square y minus sin square y is 1. Cos square y minus sin square y is 1. So what will be value of sin square y? Cos square y minus 1. Now if it is cos square y minus 1, then you will get x square plus 1 is equal to cos square y, or root of x square plus 1 is equal to cos y, and y will be equal to cos inverse of root of x square plus 1. which is same as sin inverse x. What are we trying to do? It was like sine of pi by 2 minus theta is cos theta. So inverse has a relation. Sin inverse x is cos inverse x square by 2. X square plus 1. Square root of x square plus 1. You can try their respective formulae, it will turn out to be the same. What was the formula for sin inverse x? Log of x plus x square plus 1. And what is this formula? Log of, original formula is x plus under root x square minus 1 was the formula. You are required to substitute for x square by 2, root of x square plus 1. So if you substitute, it becomes log of root of x square plus 1 plus under root of x square plus 1 minus 1, and it leads to the same thing. And that's why this relation is important. Okay, they ultimately are just the same, but we want the relation between the inverses, sin inverse and cos inverse. We'll take one problem and then the break, because then we can't sustain anything more. Why one problem? Because the problem, when I give you the problem, then just think we have learned so many formulae and now how to solve this problem. They say that if y equal to log of tan x, prove that. Number 1, sin ny is equal to half tan raised to n x minus cot raised to n x. Number 2, 2 cos ny cosec 2x is equal to cos of n plus 1 y, cos of n plus 1 y plus cos of n minus 1 y. And this becomes our very first problem when we have the entire list of formulae with us, and problem starts like this. Only hint in this problem is it is on hyperbolic, because that sin and cos is appearing. So how do we start? Right. One option is y is equal to log of tan x. Therefore, e raised to y is equal to tan x. Right. So we can start with LHS. It is sin ny. By definition, it is e raised to ny minus e raised to minus ny upon 2, which can be half into bracket e raised to y bracket raised to n minus e raised to minus y bracket raised to n. E raised to y is tan, so it is tan x raised to n minus 1 upon tan x raised to n, and becomes half tan raised to nx minus cot raised to nx, which is RHS. cosec 2x है, h नहीं है. Now in the second problem, it is better to start from right hand side, because cos of n plus 1 y plus cos of n minus 1 y is cos of a plus b is cos a cos b plus sin a sin b, and cos of a minus b is cos a cos b minus sin a sin b. So it is ny plus y and ny minus y. So ultimately you will get it as 2 cos of ny into cos of y. Write this as ny plus y, and this is ny minus y. Out of that cos ny we require. Only question is cos y should be written in terms of cosec, and for that we will have to now do something, because it will be 2 cos ny into cos y will be e raised to y plus e raised to minus y upon 2, and e raised to y is nothing but tan x, so it is 2 cos of ny into bracket tan x plus cot x upon 2. Tan x plus cot x means 2 cos ny, it is sin x upon cos x plus cos x upon sin x upon 2. Which will be 2 cos ny into bracket, when you cross multiply it will be sin square x plus cos square x upon sin x cos x upon 2, which is nothing but 2 cos ny 1 upon 2 sin x cos x, which is 1 upon sin 2x, which is cosec 2x. Okay, we'll continue tomorrow with hyperbolic again, because now I suppose it is straight away only problems. We have done all the formulae except for that sin of x plus iy.